talked about complex numbers yesterday, and we needed those complex numbers before we dealt with quadratics. So today, we're going to talk about how to solve our quadratic equations. We will get through part of it, and then tomorrow we are going to finish this section up. Okay, so it'll be today and tomorrow we're working on this. What is a quadratic equation? It has an x squared in it. That's really the only requirement. X squared has to be the highest power. You're used to seeing like ax squared plus bx plus c equals 0. Now obviously we can have different forms. B or c might be 0, but we have to have the x squared in it to make it a quadratic. And the first types of quadratics you guys solved, you were really just factoring. And once you factored, we used what was called the zero product property. Now, if I have a quadratic, let's say x minus 1 times x plus 3 equals 0, we know that the only way we can get 0 as an answer to a multiplication problem is if one of those two things was 0. Okay, so that's your zero factor property. And so you guys probably, once you draw lines and solve it, set each of those equal to 0. And so we get x to be 1 and negative 3. And you can write them in a solution set. I am not super picky about that as long as you have the answers. So I don't care if you leave it as x equals, I don't care if you write it in a solution set, as long as you have your answers. How many answers do we get on a quadratic? 2. It's an x squared. We have to get 2 answers. Now sometimes we might get the same answer more than once, right? I could get like 1 twice for an answer. Do you remember what it's called if you have a repeated solution like that? Remember the word for that? Repeated solutions are multiplicities. So if we get the same answer more than once, it has a multiplicity of 2. It means it was a solution 2 times. And that is actually very important to note because it does impact the graph. And in here we'll be graphing not just quadratics, but several higher polynomials. And so we have to know what those multiplicities are when it comes to these. So let's try. There's a brown. Sweet. All right. Take a look at this one. If I asked you to solve this equation, what would you have to do first? Right, has to be equal to 0, so we need everything on the same side. Add over this x, subtract over the 12. Up to you guys if you show the work for that, as long as you move it all over. So we end up with x squared plus x minus 12. And then what do we do? Factor. Do you guys remember your factoring? Hopefully. X squared breaks into x. We need 2 numbers. Multiply to a negative 12 and add to a positive 1. What would that be? Negative 3, positive. And now what? Set them each to 0.
You have to show our work for that.
So you guys have to show as much work as you need. Okay, everybody's different. At the very least, I need to see that you brought everything to one side and that you factored it. But you can jump from that point and tell me the solutions, 3 and -4. You realize it's just the opposites. So that's totally fine if you skip some of those steps. Alright, how can we check our work? Plug them back into the original, and we would get an answer that way. I put in a 3, you get 9 equals 12 minus 3 is 9. Put in -4, -4 squared is 16 equals 12 plus 4, so 16 equals 16. You can check it. Alright, if you do your work right, you shouldn't get answers that don't work on those. It's not one of those types of problems where we get extra answers. What about this one? It's already equal to 0. We can't do slip and slide. What can we do? It's not actually difference of squares, but we can take out our x. Greatest common factor is always where you look first on those problems. So then set each thing to 0, so either x equals 0 or x minus 9 equals 0. So we get 0 and 9 for our solutions. Alright, I want you guys to do a problem. It's already equal to 0. Multiply to 9 and add to -6. What would that be? Okay. So you guys get x to equal 3. What I would like to get in the habit of, because later on in the semester it makes a big difference, that answer showed up twice. And so to show that it was an answer twice, we are just going to write m for multiplicity and 2 beside it. Not that you were wrong if you just listed 3, that is the solution, but the multiplicity changes our graphs when we draw these things. So we're just going to get in the habit now, so we're not trying to add in something new later on. So m is for multiplicity, it's just telling me this was a solution 2 times. Alright, what if I gave you this problem? What would you do first? Do we have a greatest common factor? No. So what do we do? Good. Add factors. Multiply to 36 and add to -12 would be -6 and -6. What do you have to remember from there? They're the same, so you can write it twice or just put squared on it. 6 over 4 reduces to 3 over 2. So that would be 2x minus 3 squared. That's my factored form. Set that equal to 0, and we get and since it showed up twice, I can write m2 for multiplicity of 2. Pretty good? Right, I'm going to put a couple more up here for you guys to try on your own. And then if we're doing okay with that, I'll move on. Alright, so we subtract over the 3. Flip and slide. Multiply to negative 18, add to 7, would be a positive 9, negative 2. What do you have to remember to do though? Divide the 6 back. So if you were just factoring, you would divide it back. 9 over 6 reduces to 3 over 2. 2 over 6 is 1/3. Set those equal to 0 and we get negative 3 halves, positive 1/3. Did you guys get that one? And of course, if you need to show that work for getting it equal to 0, definitely just write it out, solve that equation. It doesn't take long. Subtract your 3, divide by 2. On F, we subtract over the 4. What do I need to do first? GCF. We can take out a 2. Then we slip and slide. So that would factor into positive 5, negative 4. Divide the 10 back. We still have the 2 we factored out. 5 over 10 is 1/2, so 2x plus 1. 4 over 10 is 2/5, so 5x minus 2. When you set this equal to 0, technically we have 3 things. Will 2 ever equal 0? No, so that doesn't give me any answers. We really just need those 2. So we get a negative 1/2 and a positive 2/5. Alright, are there questions on those? Does anybody need me to look at their paper? Okay, I need you to stick with me for a couple more minutes. We need to mention 2 more things. So, one other strategy that we have, completing the square is what we're going to look at tomorrow, but we are going to copy that process down in our notes. However, square root method is also a very helpful strategy for solving these problems. If I gave you this problem, you wouldn't want to subtract over the 5 and try to factor it. We know we're solving an equation. It's already x equals. If I were solving it, I just have to get rid of the square. How do you get rid of a square? Square root. But if you add a square root into a problem, what else do you need? Positive and negative. So you get x to be positive and negative square root of 5. Okay, so if it's set up where it's already like x squared equals something, there's no other x's in the problem, we can do that to solve. Sometimes this can make a problem significantly easier to solve. So for instance, if I gave you x minus 2 squared equals 16. You could choose to multiply out the x minus 2, subtract over the 16, and refactor everything. But that's going to take a lot of time and it's really unnecessary. What would I have to do to solve those? Okay. If we add a square root, now be careful, this is where people make mistakes. If you add a square root, we have plus and minus. So we get x minus 2 equals plus or minus 16, or sorry, the square root of 16 is 4. However, What people do now is they add over the 2 and they tell me the answer is plus or minus 6. Why is that wrong?
Because you have to take a plus 4 and a minus 4.
Yes. This is like saying x minus 2 equals positive 4, x minus 2 equals negative 4. So when you solve that, you get x to be 6 and negative 2. Is that okay? And you can also have i's, like if I said x squared equals negative 49. What would you do? Square root, plus or minus, what is the square root of negative 49? 7i. Alright, any questions about square root method? Alright, I want you to write down, I'm going to put the process for completing the square up on the board. I want you to write it in your notes. We will start with that tomorrow. I'll put the homework up here. After you have that written down, you can start your assignment. Okay, but I want this part written down.